In the previous session, we addressed rational numbers. In this session, we're going to be taking a look at irrational numbers. As a reminder, a rational number is a number that can be written as the quotient of two integers. Likewise, then, an irrational number would be a number that cannot be written as the quotient of two integers. So what are some consistently irrational numbers that we have? Is there any special number or special function that creates irrational numbers? And one of the more frequent ones that does is the square root. But not all square roots create irrational numbers. For example, the square root of 1 equals 1. The square root of 4 equals 2. And as we can see in both of these cases, we are given a whole number answer. Well, that whole number can be rewritten as a quotient. And the quotient in this case would simply be 1 over 1. The quotient in this case for number 2 would be 2 over 1. So we can see that any time a square root of a number gives us a whole answer, an answer that is an integer, since that integer can be rewritten as a quotient of two integers, that original square root itself of that number is rational. However, many square roots are irrational. Square root of 2 is one of those. Square root of 3 is another. Square root of 5 is another one. Square root of 7 is also another one. In other words, there is no number multiplied by itself that will give us exactly 2, because when you calculate out the square root of 2, the number goes on forever and there's no repeating pattern of digits. It just keeps going on forever and ever with no repetition whatsoever of the digits. So the square root of 2 produces an irrational number, the square root of 3, 5, 7, and so on. Basically, any square root that does not produce an integer as an answer, so the next square root after 4 that would produce an integer as an answer would be the square root of 9, because that would give us 3. The one after it would be the square root of 16, which gives us 4. Basically, if you have a square root of any other number than one that gives us an integer as an answer, what you're going to be getting is an irrational number as an answer. The same holds true for trying to find the square roots of a fraction. So let's come over here. If we were to say the square root of 1/2, well, that also would create an irrational number. However, the square root of 1/4 is 1/2. 1/2 times 1/2 equals 1/4. 1 over 2 is a rational number. The rational number is the quotient of 1 and 2. So in order for a fraction to have a square root that produces a rational number, you have to take a look at both the numerator and the denominator of the fraction, and both of those have to be the square of another number. Well, let's take a look at our 1/4 again. Is 1 the square of another integer? Yes, it is. It's the square of 1. 1 squared is 1. Is 4 the square of another integer? Yes, it's the square of 2. 2 squared is 4. Let's take it on even further. Let's say we had 1 over 16. Is 1 the square of a number? Yes, it's the square of 1. And 16 is the square of 4. So the square root of 16 is a rational number, and that rational number is 1/4. Over here, though, 1 and 2, 1 is the square of a number, but 2 is not. So even though the top number, the numerator, is the square of another number, since the denominator is not a square of another number, the square root of this fraction is irrational. And we can do that for any numerous types of fractions. They don't just have to have 1 in the numerator. The square root of 7/11. Is 7 the square of a number? No, neither is 11. So what type of number will the square root of 7/11 produce? It'll produce an irrational number. What about the square root of 16 over 49? Is 16 the square of a number? Yeah, it's the square of 4. And 49 is the square of 7. Therefore, the square root of 16 over 49 is a rational number, and that number is 4/7. So once again, the main difference between a rational number and irrational: rational numbers can be written as a quotient of two integers. Irrational numbers cannot be written as the quotient of two integers. One other quality that I want to point out here is that irrational numbers can occupy places on a number line. So on the number line, I just went ahead and created here. I've gone ahead and placed three irrational numbers on the line. Over here at the right, we have the square root of 7. That's indicated by this point. The square root of 3, which is indicated by this point here. And then over to the left in the negative numbers, I have the negative square root of 5. So even though irrational numbers have no repeating pattern of digits, they cannot be written as the quotient of two integers. They still hold positions or places on the number line. Review time. Irrational numbers are numbers that cannot be written as the quotient of two integers. Many square roots create irrational numbers. And then the square root of a fraction that's already been reduced to its lowest terms is rational only when the numerator and the denominator of the fraction are both squares. That'll finish up session 97 on irrational numbers.